Yesterday in the last class, I have discussed with you the train accuracy, train test split. I have discussed with you the train test split. So what is meant by train test split is whatever the data we are having, we are going to divide into two parts. The data will be divided into two parts. One part is for training purpose and one part is for testing purpose. Now, what I'm going to show you is example. I'm going to take randomly some example of X and Y. That example also, you are going to tell me the values. You only tell me the values. What are the values? So some person, please tell me some X values. 8. Continue, please. At least 10 values. 7. 3. 9. 15. 3, 6, 25. Remember that you have to do the calculation. Manual calculation you have to do. Don't forget that one. Okay. I can also tell 10 crores, 28 crores also. Calculation has to be done, right? After that. 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is completed. 10 values. Similarly for Y values. Choice is yours. Guys, fast. Accept that person. Only that person is there in the class. Right? Now we are having the data set like this. This data set was created by you and you're only going to tell me the answers. And I'm going to tell you whether the machine learning will work on this data set or not. You have given a worst data miss, worst answer only will get. Nice data miss, nice answer will get. Okay, accordingly. Whatever the data set, according to that answer will be, we are having. Right? Now here we are having the data set with respect to X and Y. 10 values have taken randomly. Now whatever the values of X and Y is there. Now using this X and Y, first I'm going to split the data into two parts. So what I'm going to do is this part I'm using for testing purpose. This part I'm using for testing purpose. And this one I'm going to use for testing purpose. Randomly I have selected 3 values. Okay. Why you have selected those 3 only? Don't ask the question randomly. Okay. Now whatever the remaining values are there, X train. What are the remaining X train values? That is 8, 7, 11, 9 also will be used in the testing purpose. 15, 25 and 6. Okay. So here I have selected with 70% of training and 30% for testing. For example, I have selected with 80% for training purpose. This is the maximum value. For training, you have to give the maximum value of 80. So here I'm going to select 49, 47 and 6 also in the X train. Okay. Now Y train. Corresponding Y train values. 27, 1, 13, 9, 13, 15, 0, 9. Right? This is X train, Y train. Similarly, X test, Y test. What are the X test values? 3 and 9. Y test values are 5 and 7. Okay. Now this is the 5 and 7 for testing purpose. Now data is ready. The train test split concept is completed. So we have taken randomly 8 values for training purpose, 80% of the data for training purpose, 20% of the data for testing purpose. Train test split only has done. Now, after this train test split, whatever I'm having here, just I'm writing the same thing here. So instead of wasting the space, that is 3 and 9 and 5 and 7. Okay. Now, from here, I have divided the data into 2 parts. That is for training purpose and testing purpose. Now, whatever the data, these 8 records data is there, right? Using these 8 records, I'm going to make the model. Model means I'm going to use the model linear regression. That is y is equal to f of x. And I want the equation in terms of beta naught plus beta 1 x only. And you have to identify the beta naught values and beta 1. How to identify beta naught and beta 1? I already told you the mathematical formulas. Now using that one, you are going to calculate the beta 1 and beta naught and beta 1. Assume that you have got the beta naught as some value of assume. I am not calculating assume. Assume you have got with 4.2 and this one is 9 something. Or this one has 2x. 4.2 plus 2x. You have got some values like this. Assume. This is the equation. Now using the equation, Now using the equation, this is important. Please focus now. Using the equation, now you are substituting in the extrain data. You are substituting the extrain data. That is 8 you are substituting, 7 you are substituting, 11 you are substituting, and you are going to predict the values of y hat. Now you are substituting extrain data inside this equation. Inside the equation, you are substituting the extrain data and you are predicting the y pred of the train data. And you are going to get some values. How many values you will get? Total 8 values you will get. Now using these 8 values of original data, 8 values of test data, you are going to compare between these two and you are going to calculate the whatever the accuracy. The accuracy in terms of R square or the accuracy in terms of RMSE value, either error wise or R square wise, any one. If you go with RMSE or R square, anything of your choice. One gives with respect to error, one gives with respect to accuracy. Now, for example, I am considering accuracy, the word of accuracy, which is R square. Now, whatever the accuracy I have calculated between the original data versus predicted data, whatever the accuracy I have got is called as train accuracy. Now, within these equations, equation will not change. Inside the equation, now this time I am substituting the X-test data. Now, what is the X-test data? These are the 2 data points. These 2 data points, first I will substitute the 3 here and I will get the value. I will substitute the 9 here and I will get the value. Now, how many predicted values will be there? 2 values only will be there. This is called as y pred of test data. Now, I am going to compare these 2 values with these two. These two will be compared. I can't compare this one with this one or this one with this one. These 8 records has to be compared with respect to these 8 records and you have to calculate the train accuracy. These 2 records you have to compare with these 2 records and this is called as test accuracy. That is R square for this one separately, R square for this one separately you are calculating. Accuracies you have calculated. Now, if the train accuracy is very high, test accuracy is very low. If one of them is very high, train accuracy is very high, means the model is understanding the given data very clearly. It is understanding whatever the given examples are there, very clearly it is understanding the given data, but on the test data, means new data, whenever you are applying a new data, it is failing the values. It is not able to predict the more accurate results. So when the train accuracy is greater than test accuracy, it is called as overfitting problem. Means in the class, if I explain something to you and if I'm asking the questions, means you are giving the reply, you are shouting, sir, if this is the thing, miss, how to calculate beta naught? Miss, if I ask, miss, you shout that, sir, beta naught will be calculated by y bar minus beta 1 into x bar. How to calculate beta 1? Sir, sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square. If you are shouting like this. Now, train accuracy is very good. Now, the same question was asked in the interview. You are sitting silently and seeing that at the interviewer face. Then what is the meaning is, it is called as overfitting. Overfitting means train accuracy will be very good, test accuracy will fail. Similarly, train accuracy is low, test accuracy is very high. Then it is called as underfitting. What is the meaning of this one means, for example, in the class, if I'm asking the questions, you are sitting silently and you are seeing at my face like this. But in the interview, you are performing very well. Assume. Sir, at the end, you want interview performance and you want the job only. Na? If I'm sitting silently in the class, what is the problem for you? Means, in the class, why you are sitting silently? Because immediately you are not able to understand the given, whatever I'm saying. After going to home, again, you are after practicing for 1 or 2 times, then only you are able to answer the questions in the interview. Means, you are a slow learner. Means, the meaning of that is, you are a slow learner. When you are a slow learner, when I'm having in the comparison with same person like you, other person is there, but he's understanding very fastly, then which priority I will give? If there is no other person, miss, I will give the priority for you only. If assume that one more person also is there. He is understanding very fastly. Now assume there is 2 students, student 1, student 2. 2 students are there. Student 1 is keeping, in this class, he is very silent. Silent in class. In the interview, performance is nice. Student 2, in class performance is nice, at the same time interview also nice. Both of them are nice. Now, which one yours choice? Assume you are the trainer and you know both of them. Now, which student you will select? Obviously, this one only, right? Because he is actively participating in the class, at the same time, he is able to give the answers in the testing also. Real-time interviews also, he is active, and during the class also, he is active. So, that purpose reason. For example, he has failed in the test, means though he is active in the class also, there is no use. One of them, it is very silent, and others, it is also, there is no use. This is also no use. One is called as underfitting and one is called as overfitting. So in the real life also, we are going to apply now the machine learning algorithm. Whatever the machine learning algorithm I'm going to apply on the trained data, using the trained data only, I'm predicting this model. This model was given based on the trained data only. I'm not using this data for predicting the model. Using this data only, I'm predicting the model. So after predicting the model, just I'm substituting this X train values into the given model, and I'm predicting the values of Y train, and original answers and predicted answers, I'm keeping them side by side. I'm checking the errors of each record, and I'm calculating the error, that is mean square error or root mean square error or R square, whatever I'm calculating. And if this performance is very nice and this performance is very low, it is called as overfitting problem. If one of the performance is high, other performance is low, miss, this is called as underfitting problem. Test accuracy is high and train accuracy is low, miss, underfitting problem. I want the answer in such a way that train and test both should be almost close, not exactly. The deviation between train accuracy and test accuracy should be plus or minus 5%. It should not be with respect to high. For example, in the class, if I'm asking any particular student, okay, in the class, I'm asking the student some questions, I'm asking randomly. Whatever I have trained in the class, I'm asking randomly, and he has given 90% of the correct answers. The same person, he has went for the interview. In the interview, the person is asking the questions, and this time he has given only 40%. What is the meaning, miss? It is overfitted. Miss, why he is having 90% accuracy in the class? Because he is free, because he knows about the SRK sir, and if I say wrong answer also no problem, and he is opening the mouth and he is not having any kind of pressure. He is saying whatever the answers. In that 90% of the answers are correct only. Though he know correct answer also, due to fear, will not open the mouth. In the real-time interview, though we know the answer, but due to some fear, if he says wrong answer, he may not select us. We'll have that fear. If you don't answer also, he will not select. Nah. Instead of keeping silent, saying better answer is better, right? If you have told wrong answer also, he will not select. If you don't say answer also, he will not select. Instead of that, if you try means, there may be probability that he might select. So that is the reason in the interviews, we have to open the mouth and we have to answer every question, try to answer every question. Whether it is right or wrong, that is secondary. We have to try to answer. So in order to get the correct answers, we have to practice well. So here, similar way, practice well means we have to understand the subject very well. Subject understanding means nothing but machine learning also should be done very well. How I can understand the machine has understand the data very well means if the train and test accuracy is almost close, then it is good model. If the train accuracy is less than test accuracy or train accuracy is greater than test accuracy means it is called as overfitted model. For example, in the class, I am explaining for you for loop. For I in range of something I have shown you and I have explained some simple code. Just I have changed the number and I asked one question and you have answered that one. But this time I have given somewhat complicated question. You are not able to answer. Then what is the meaning? That example is very clear for you, but another example is not clear for you. Concept clear, example clear means example is clear for you. That is the reason you are answering that example. If I change the numbers also, you are able to answer because that example is clear, not the concept. Example is clear. Now the changing of numbers is very clear for you. Right? So in the machine, now the same thing I'm correlating between both of them because the reason behind this is the way you have to learn. That one also you have to check yourself. The train accuracy means inside the class, whatever you are doing the practice and whatever the data set you are selecting, that you are doing the same thing and you are understanding each and everything means okay. After that, immediately you have to check the test accuracy also. How to check the test accuracy means you have to open the same concept name in the internet. Go to the Google, interview questions on linear regression. You will get the interview questions and you have to answer that interview questions. That is called as test accuracy. If you feel that, okay, sir, linear regression concept is very clear for me, immediately go and check in the website that interview questions on the linear regression. Right? That is called as test accuracy. Now, the train accuracy and test accuracy is almost close means it is called as a good model. If one of them is high means it is called as overfitting. If one of them is low means it is called as underfitting. Is that clear? Sir, now overfitting means how we can reduce the overfitting. If it is underfitting, how we can overcome to that one that we have to see in the further. Okay, we'll see. I will show you multiple examples with respect to where there is overfitting also is there and how we can resolve that overfitting. You'll see in the future. Don't worry. Right. So finally, which model you have to select means the model should be having the train accuracy and test accuracy almost close. Means once you prepare the model, using the model, you have to predict on the train data, and using the model, you have to predict on the text data. Both the things you have to predict. You should not predict only on the test data. You should predict on the train data also. And you have to compare with the original values of train data, original Y versus predicted Y of the train data also you have to check, and you have to calculate the train accuracy separately. Train accuracy is not always 100. You think that 100% it will understand perfectly. No, it may not understand also. For example, for this data set, if you calculate, train accuracy will not be 100%. If you want, you can try. Take the same data set and you can try. And calculate the train accuracy, manual calculation. In the interview, now I have asked you the questions means I asked randomly, tell me 10 values. Na? In the interview, we will ask you, randomly tell me 5 values of X and 5 values of Y and apply the linear regression. We will see whether you know the max behind that or not. And how to predict the answers and how to, I will ask for this data set, don't go with the Python coding. 5 values of X and 5 values of Y. Take anything of your choice. For that, calculate the train R square, calculate the train test R square. I'll ask like this. Without using the Python code. Don't open the Jupyter notebook or anything. Don't open the Python. Just do whatever you want. Calculate the train R square, test R square. And tell me whether the model is overfitted or underfitted. Assume this is the complete data you are using. In this 5, you select one data for testing purpose. One data for testing purpose and remaining 4 you take for training purpose. Anything as per your choice. Now the question is, sir, okay sir, randomly we are choosing now. These 2 records randomly we are choosing. Fine. Now question is, for example, let us take an example. Here I'm writing with different color. So I have used it for training purpose some data. In the class I'm explaining. And I told you for testing purpose, you have to open in the Google interview questions on the linear regression and you will get the interview questions and check yourself whether you have understand the topic or not. This is called as testing. Now, in the first website you have opened. In that first website, easy questions are there. And you have got 100 out of 100. The meaning is, linear regression 100% perfectly. Yeah? Maybe, may not be. Now, what we have to do? We have to open the second website. In the second website also, how much score you are getting, you have to check. Open the third website, open the fourth website, open the fifth website. Like this, you try with different. This is called as cross-validation. The same thing which we are going to apply now. Today's topic is with respect to train accuracy, test accuracy, what is meant by overfitting, underfitting, and cross-validation. So we are not going to check only on this data. We'll apply the cross-validation by selecting different. For example, these 2 went for testing purpose means this is the answer. If, for example, instead of these two has went for testing purpose. Now, this time these 2 has went for testing purpose. Now, this time this one and this one has went for testing purpose. Now, so like this, we are going to apply that is called as cross-validation. So if this data was selected randomly. If different data was selected, different answer. Na? Train accuracy will be different and test accuracy also will be different because train accuracy will be dependent based on the X bar. If different X value is there, automatically X bar also changes, right? Y bar also changes, right? Automatically X bar and Y bar changes means sigma of X bar, X minus X bar into Y minus Y bar value will change, right? Automatically. For different values, test accuracy will changes, train accuracy also will changes according to the data. Is that clear? So here we are going to understand 1, test accuracy, 2, train accuracy, 3, what is meant by overfitting, what is meant by underfitting, what is meant by good model, and along with the cross-validation. For every algorithm, we have to apply all these things. For each and every algorithm, we have to apply. Not simply model fit on the X train, Y train, not completed. After that, model selection is more important. We have to evaluate the model, whether it is a good model or a bad model. In the class, if I explain something for you, it is not completed. We have to check now whether you are understanding or not. If you're not understanding, what is the problem? Where? That we have to do, right? Simply if I am saying miss, without you, I can say to whiteboard also, right? To wall also, I can say directly. Then what is the use of sitting in front of students? I'm not speaking to the wall, right? I'm speaking and I'm explaining for the students. So I have to take the questions from the students. And whether the students are understanding or not, I want to check the test accuracy. I'm going to measure your accuracy, test accuracy. Train accuracy, I will do in the mock interview. Test accuracy is called as Kaggle. Your Kaggle is your test accuracy. Right? And I want to apply the cross-validation. Cross-validation means along with the Kaggle, cross-validation is NASCOM certification. If you are able to crack the NASCOM or not. Kaggle, you are getting better rank, but NASCOM, you are failing, miss. If you are understanding the data science concepts very clearly, any kind of certification in the world, you have to crack, right? If the syllabus is matching. If the syllabus is not matching, miss, according to that, we have to learn that particular syllabus. If the syllabus is same, miss, any certificate in the world, we have to crack blindly. Right? So here we are going to understand with respect to this test accuracy, train accuracy, and whether it is a overfitted or underfitted. This is 100%, not 100%, 1000% interview question. For data scientist, without this, there is no interview question. Data scientist, particularly for data scientist, I'm saying. Data scientist interview question, most important interview question is overfitting and underfitting is the most important question. And based on this question and cross-validation only, we'll understand whether the person knows the subject or not. One of the most important interview question. 1000% blindly. Without this question, there is no interview only. 100% they have to ask. Right? Now, what is the meaning of test accuracy? Write in your notes very clearly. First, we have to take the training data set. First, step number 1. Split the data into training purpose, train and test. Split the data into train and test, 2 parts. Within the train, we are having X train, Y train, both of them. Similarly, test also X test, Y test. Right? This is step number 1. You have to split the data. Step number 2. You have to apply the ML algorithm on the train data. Train data means that is nothing but X train and Y train. By using X train, Y train, you have to build the model and you have to identify the relation between X train versus Y train. Okay, apply the ML algorithm on the train data. What are the ML algorithm? Not only linear regression. Every ML algorithm, including deep learning algorithms, same concept. After that, step 3. Okay, predict the Y hat values on the train data by giving X train as the input. By giving X train as input to the model. This much of detail I have never explained to any batch. Okay. Generally, they'll write running notes. I'm writing first time. Predict Y hat on the train data by giving X train as the input to the model. Means nothing but Python code is model.predict on X train. This is the Python code. Now, these X train values will be given to the model and it will predict the values. Whatever it is predicting, you have to save it as ypred with train. Ypred of train. Right? Next, once this is completed, next step number 4. Now predict the same Y. Again, predict the Y on the test data. This time you predict on the test data by giving X test as input to the model. By giving X text as the input to the model. Right? Next, step number 5. Calculate the calculate train R square and test R square separately. Calculate the train and test R square separately. Each of them separately calculate. So calculate train R square separately, test R square separately. Once both of them is calculated, now next step number 6. Step 6. Check whether the model is overfitted or underfitted. Check whether the model is overfitted or underfitted. And along with that, check the cross-validation score. Cross-validation score is equal to test accuracy or not. So for example, if you say that, sir, I have tested myself in the website, sir, first website, and I have got 90%. And you have to try with all the remaining 4 websites or 5 websites or 10 websites. Now, average of all the 10 websites, if it is still 90 miss, okay, then I'll accept it. If the remaining websites, your accuracy is very low miss, this test accuracy is this website is the easiest website, or this website is not with respect. We can't decide based on the single website, whatever the questions are there. Is that clear? So now the same thing, whatever the steps are there, everything I'm going to do them manually. Without using the Python, I will show you the manually with a simple example. Don't expect a complex example. Because I can't do the complex example calculation. I can't open the calculator, all these things. If you are interested, you can open later. After the class, you can practice on whatever the data set you are interested. Okay. So what I'm going to do is here, X and Y, I'm going to select 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My simple example I'm selecting. Now step number 1 is, what is the step 1? Split the data into 2 parts, that is train and test. So what I'm going to do is X train and Y train. Similarly, X test and Y test. So X train, Y train, 1, 2, 3, 4, 6, 7, 8, 9. This I'm using for training purpose. 5 and 10 I'm using for testing purpose. Randomly I have chosen. Last record I have chosen for testing purpose. Randomly. This is step number 1. Next, step number 2. What is step number 2? Apply the algorithm on the train data. That is this one. You have to apply the data. Assume this is the only data with you. Forget about the 5 is not there. Now for this data, you have to calculate accordingly. That is average value of this one. X bar you have to calculate. Y bar you have to calculate. X minus X bar. In next one is Y minus Y bar. Next one is X minus X bar into Y minus Y bar. After that, you have to do the sum of X minus X bar into Y minus Y bar. And from that, you calculate the beta naught is equal to sigma of X minus X bar into Y minus Y bar divided by summation of X minus X bar whole square. So here you have to calculate X minus X bar whole square also. And whatever the values, 4 values you are going to get, 1, 2, 3, 4. And you have to do X minus X bar whole square also. And using that beta naught, beta 1 you will calculate, and beta naught we will going to calculate with respect to by using Y bar minus beta 1 X bar. Now, if you want the calculation also, I will do the complete calculation also. This is very simple example only, so I can do manually. 3, 6, 10. 10 means 2.5. 13, 21, 30. 30 divided by 4, 7.5. So, 1 minus 2.5 minus 1.5. 2 minus 2.5 minus 0.5, 3 minus 2.5 plus 0.5 and 1.5. And similarly, 6 minus 7.5 minus 1.5 minus 0.5 plus 0.5 plus 1.5. This both 1.5 into 1.5, 2.25. This one is 0.25. This one is again 0.25 and this one is 2.25. This one is again, this one also 2.25, 0.25. 0.25, 2.25. Now the sum is 4.5 plus 0.5, 5. This one also 5. So 5 divided by 5, beta 1 is equal to 1. This one is 7.5 minus beta 1 is 1 into X bar. That is 2.5, which is nothing but 5. So now finally the equation is equal to y hat is equal to beta naught plus beta 1 x, which is nothing but 5 plus x. Done. Step 2 is completed. Apply the ML algorithm on the train data. I have applied only on the train data. I have not selected the test data. Only on the train data I have applied what are the things I want to do. Done. Is that clear? So if I want to do the step 3, I have to delete this one. If it is okay, miss, I will delete. Everyone has written? For one algorithm, I am going to do the max. For remaining 20 algorithms, you will do the max. Similar way. Right? Coding part is easy. So for this, what is the code you have to write, miss? Xtrain. If you want, you can write the Python code also. Write in the notes simultaneously Python code also, so that it will be easy. What are the Xtrain, comma. Next one is X test. First, X will be split into 2 parts. After that, Y will be split into 2 parts. That is Y test. Is equal to train test split. Train test split of X comma Y with test size or test train size of 0.8. You can write either test size or train size. Train size. I am writing train size is equal to 0.8. Means 80% I am using for training purpose. This is the one. For this one, what is the code I have to use, miss? Just whatever the linear regression model is there. Linear regression model. I am going to save it in a model, linear regression. First I have to import. In this case also I have to import this one. In this case also I have to import. And whatever the model is there, model.fit on Xtrain, Ytrain is the code. Python code is this one. When I have done like this, automatically in the backend, this will be done. In this case, in the backend, it will done like this. In this case, it will done like this. In this case, it may select any data. It is not compulsory. This fifth record only will be there in the test. Anything can be there. But here, whatever the data you have given in the Xtrain and Ytrain, that one only will be fitted. This Xtrain and Ytrain, whatever the data is there, for that only it will apply this one and it will identify the relation. Completed. Step 2 is completed. Now, what is the next one? Step 3. So, what is step 3? Predict. Predict the Y pred, that is predict the Y values on the Xtrain data. Now, first you select the Xtrain data. What is Xtrain data? That is 1, 2, 3, 4 is the Xtrain data. Now, you have to predict the Y hat. The Y is 6, 7, 8, 9. The original Y train is 6, 7, 8, 9. Now, you have to predict the Y hat of the train data. Means nothing but first you have to take the equation. Whatever the equation is there, that is beta naught plus beta 1 x. That is 5 plus 1 into x. Whatever is we are having, this is the equation. Substitute these x values here. First you substitute 1 here. You will get the value. What is the value? 6. 2 you substitute here. 1 into 2, 2. 2 plus 5, 7. 3 into 1, 3. 3 plus 5, 8, 9. You are going to get this one. And for this, what is the code you have to write, miss? Whatever the model is there, model dot predict on X prime. You have to write the code is called as this one. This is the Python code. When you have written the Python code of this one, this is the output. This is the output of this code. How it has worked, miss? Just it is substituting these values in the equation. Just it is substituting the values in the equation and it is predicting the values. This is the output. Right? Next, what is the next step? Step number 4. Step 4 is with respect to predict again Y on the test data. So now what it is going to do, miss? So now X test and Y test. X test and Y test. Now X test is 5 and Y test, original test is 10. Now using your model, same once again, y hat is equal to beta naught plus beta 1x. That is nothing but 5 plus 1 into x. The same equation. This time you have to substitute this value here. And whatever the value you are going to get, that is y pred test, which is nothing but 5 into 1 plus 5, 10. 10 is the predicted answer. 10 is the predicted answer. So for this, what is the Python code you have to write is, what is the Python code? Model dot predict on the x test. This is the Python code and this is the output. If you write the code, this will be the output. This is the output. If you write the code like this. In the backend, what it is going to do, this x test value, whatever is there, it is substituting in the equation. Whatever the model equation is there, it is just substituting there. Done? Completed? Now, this prediction also completed. Now, what is the next step you have to do is, you have to calculate the R square value. Train R square, test R square, separately. R squares or RMSs, anything. But accuracy is quite opposite to error. Accuracy is very high, means error is low. Error is low, right? So now I'm calculating the train R square. So for calculating the train R square, what is the train R square formula? That is 1 minus sigma of y minus y hat whole square divided by sigma of y minus y bar whole square. So now y hat values are there. Y bar values, nothing but, what is the y bar? Which is nothing but 7.5, 7.5, 7.5, 7.5. 4 7.5 is the y bars. Okay. In your notes, don't write here. In your notes, again, write from the starting. Clearly. So this is once again, you are having the y bar values and y hat values. Both of them are there. Now what you have to do? Y minus y hat whole square you have to calculate. That is nothing but, what is y? 6. 6 minus y hat. What is y hat? 6. That is 0 square. 7 minus 7. 8 minus 8. 9 minus 9. That is 0, 0, 0, 0. The sum of y minus y bar whole square is 0 in this case. Now, similarly, y minus y hat y bar whole square you have to do. That is 6 minus 1.5. 6 minus 7.5 whole square, which is nothing but 2.25. 7 minus 7.5 whole square. That is nothing but 0.25. 8 minus 7.5 whole square. That is again 0.25. Similarly, 9 minus 7.5 whole square, which is nothing but 2.25. Sum of y minus y bar whole square is equal to 10. Total is 10. Sorry, 5. Just 5. Okay. Now, train R square. Whatever the train R square is there. Now, how to calculate the train R square? This one is there, this one is there. Now calculate the train R square. Train R square is equal to 1 minus sigma of y minus y hat whole square divided by sigma of y minus y bar whole square, which is nothing but 1 minus 0 by 5, which is nothing but 1. Now, since I am writing and I am explaining this one, so some of the students will write this one. Now, whether they are focusing on this area, I am writing this line and I am explaining. And you are writing in your notes this one. You are focusing on this one, this one. What I am saying you are focusing, or what you are writing you are focusing? Understanding the logic? Now, if you understand the logic, so when I am explaining, don't write anything. Just focus clearly. After that, you write everything. If it is clear, write in the notes. If you are not clear, first you have to ask. For example, in the flow, I have deleted also. Already you have focused and you have understand the concept now. You can write it with your own handwriting, right? When you ask, sir, please, sir, wait, sir. When you ask like that, if you don't understand, you want to copy. Then only you ask like that. If you understand, if I erase also, you can write on your own, right? Understand. Just understand the logic. First, when I'm explaining, just if you focus, means the concept will be very clear. Instead of simultaneously writing, what you will get while writing? Writing also equally important. I'm not saying that it's not important, but After understanding only, you have to write. If required, you have to raise your hand, sir. Wait, sir, I'm writing. Did I stop anytime? Why you are saying your friend and you are saying like this? You are only saying, miss, I'm erasing off. If you ask, sir, stop, miss, I'll stop now. Or I will write once again now. Since you are not asking any question, I'm erasing. Right? So please learn the way how you have to learn actually. Writing is not important. Understand the concept is important. Right? Similarly, X test. Whatever the X test is there, X test is 5 and Y test is 10. Now, Y pred test also I have predicted with respect to that answer is 10 only by applying the model. Now, what is the Y bar? Y bar is here only one value is there. For one value, summation is 10 divided by 1. Y bar also 10 only. Now, Y minus Y hat whole square. That is 10 minus 10 whole square, which is nothing but 0. And sum of Y minus Y hat whole square is also 0. Similarly, with respect to Y minus Y bar whole square, that is 10 minus 10 whole square, which is again 0. Sum of Y minus Y bar whole square is nothing but 0. So there is no difference. Now, what is the test R square you are going to get is again with respect to 1. Right? So now train R square is 1 and test R square is 1. Now, whether the model was overfitted or underfitted, now I am going to cross check. So the same thing, if I write in the coding part, the same to same answers I will get. Whatever you have seen now, every step by step, whatever the output is there, every value will be the same in the coding. There, I am going to use the shortcuts with respect to by using the functions. In the every function, the backend code is with respect to for loop. They have taken the for loop and applying the same logic, whatever I have done the manual calculation, they have created the columns. In the backend, that is the code they have written. Right? Now, of course, if you want, you can write. Now you can write. Yes. Yes. In my case, I have taken with respect to the value of directly this one as 0. Actually, if you divide 0 by 0, it is undefined value. Is that clear? This is a simple example I have selected. After the class, you try with different values. Before trying with the different values, first you do everything in the notes. Don't apply the Python code. First you do everything in the notes. Take the calculator, sit and you practice everything you do in the notes. And later, if everything is perfect, now you open the Jupyter notebook. Now you apply the same logic there. And check this one. Here the thing is that machine is that thing, sir, in this, what is there machine learning, sir? Everything max only is there now. What is machine learning? Here the machine learning is identifying the relation between Y and X is the machine learning. So for example, if I give for you 1 plus 2 is equal to 9, 2 plus 3 is equal to 14, 3 plus 4, what is the answer? If I ask like this, now what you will apply, some logic you will apply, right? Okay, 1 plus 2, 9, they are saying means something is there. Okay, 1 plus 2 is equal to 9. 9 means actually 9 into 3 square. It is making square. 2 plus 3, 14. Appa, these two are not applicable now. Then how we can get that one? So something you are applying, right? What you are doing indirectly in the back end, you are identifying the relation between these two. What is the relation? And this relation is getting satisfied for the second one also, not you are checking. And if the relation is satisfying, then you are predicting for the third one. Unknown data you are predicting. If the relation is not satisfying, you are trying to get one more relation, different relation you are trying to get with that. That same thing you are doing with your human brain. Na? The same thing, give the data to the machine and machine will predict the answer. Now the same question is there na? For machine, how to give it, right? This is x1 variable, x2 variable and y variable, 1, 2 and 9, 2, 3 and 14. Fit the data. It will only identify that answer. The same example I'm going to show you in the Python coding. So first I'm going to take the model. Import pandas as PD. Just a minute. Right. There is a person with some person with dot. Person dot. Please rename yourself. Dot person. Can you please rename with your actual name? Guys, me. Who is me? Person me. Please rename yourself, please. I have given the option to rename. Please rename. Everyone, please rename to your name whatever you have given in the Naresh IT with the same name. Please rename. Rocky Bhai. Please. It is not KGF movie. Please rename yourself. Rocky, please rename. And the person with dot, please rename. Otherwise, I'll remove. If you're not interested, miss, not a problem. Just I'll remove. Dot. Are you interested to rename or should I remove? Okay, you're not there now. Anyways, if you're not there, miss, what is the use? Remove. Be in the waiting room only. Let us see others. Rocky, have you changed? Your fans are waiting here. Please change. Me. Please change, rename. After your name, there is a 3 dots. Click on the 3 dots and rename yourself. The person with me. Whether you'll replace or should I remove? Just wait for 2 minutes. We'll decide. Guys, please rename yourself. After this example, I'll remove you. Okay. So first we are going to import the pandas and I'm going to take the data frame with X and Y, whatever the example I have told you, the same example, right? Now, so import pandas as PD and data frame, whatever the data frame. And I'm going to select the X value as the X variable and Y as the Y variable. Now, once I'm applying the train test split, now whatever the X train is there, 1, 2, 3, 4 was taken. So I'm not going to take the 4. I want the 5 in my test data. So I'm executing once again without random state. Once again, let us try. Now 5 was taken automatically in the X test, right? So now what else the X test is there, miss? Your X test will have with respect to 5. Okay. 5 is in the X test. The out and 1, 2, 3, 4 are in the X train. Similarly, Y test, Y train. Let us check with respect to our Y train. Sir, why you have selected like that only? Because to cross verify our answers and that answers should cross verify. Na? So that is the reason I have selected that one. So 6, 7, 8, 9 and in the Y test 10 will be there. The balance 10 will be there in the Y test. Okay, X test and Y test. Is that clear? Step 1, whatever you have written in the notes and whatever the Python code, both are same. Let us click on the save. Okay, both are same. Now, next, what we are going to do? We have to fit the model with the X train and Y train. So from sklearn.linear model, I'm going to import the linear regression and I'm going to fit on the X train and Y train data. I'm going to fit on the X train, comma, fit on X train, comma, Y train. Okay, fitting is done. Now after fitting, now what you have done, the mathematical calculation, you have calculated the beta naught and beta 1 values. First you have calculated the beta 1, that is quotient value. Beta 1 was calculated, which is 1. And after that you have calculated the intercept value, which is nothing but 5. Both are clear. So equation is also same. Whatever the equation is with respect to y hat is equal to beta naught plus beta 1 x, where beta naught is 5 plus 1 into x. Same equation we have got. So step 2 is completed. Now what is the step 3? Model dot predict on the x train. You have to predict your model on the x underscore train, on the x train data. Okay, and whatever the output is there, I'm going to save it as ypred train. So the name it as ypred underscore train. So the same output, let me check whether the same output I'm getting or not. So the same output, that is 6, 7, 8, 9. So in our case, just order is changing, but same output. Similarly, ypred on the test data, I'm going to do on the test data. That is with respect to x test. You are applying on the test data. And whatever the output you are getting, you are writing as ypred test. Ypred test. 10 is the same. Step number 4 also clear. What is the step number 5? Calculate the test R square and train R square separately. So calculate the model dot score. You have to apply model dot score on x train. Take the x train, comma, y train. X train, comma, y train. Now it is 1, which is 100%. Similarly, on the test data, same thing on the test data, that is model dot score on the x test versus y test. So you will get the accuracy score. Here it is saying that infinite. As one of the student has told, 0 by 0 it is selecting. So that is the reason it is showing as infinite. So it is showing an warning with I can't define the value, because both of them are same now. 0 by 0, where var square was calculated based on 1 minus of 0 by 0. So when it is having infinite, 1 minus infinite also with respect to infinite. So that is the reason it is showing that some kind of error. Okay. So here if you observe this one, so this is the way. First we have to do the modeling. These 3 steps are called as modeling. These 2 steps are called as prediction. And this one is called as evaluation. After evaluation, so first one is modeling. Modeling of 3 steps. So you can write in the notes clearly. Again, Python code. Keep the heading as Python code. Okay. For entire machine learning. For every machine learning algorithm, this is the common code. Common code means not every time linear regression. We have to change the algorithm. First one is modeling. First one is modeling. Within the modeling, step 1. Within the modeling, step 1 is import the algorithm. Import ML algorithm. Whichever the algorithm you are working, import that one. Step 2 is save that ML algorithm into a model. Save that ML algorithm inside a model. Step 3 is fit the model with X train and Y train. Fit the model with X train, Y train. These are the 3 lines of code called as modeling. Every time. The only difference is algorithm name will change. Coding will not change. 20 algorithms are there now. 20 algorithms, only import will change. Only this line will change. Remaining everything copy paste only. So coding is easy in the machine learning. Okay. Next one is prediction. Next heading is prediction. Inside the prediction, again step 1, step 2. Step 1 within the prediction is predict on X train. Predict on X train. Again, predict on X test. These 2 are called as predictions. Predict on X train and predict on X test. Separately. Right? Next, finally, evaluation. Next step is evaluation. Evaluation means calculate the train R square. If it is regression problem, train R square. calculate the test R square. If it is regression problem, if it is other problems, according to that will be there. If you want to calculate errors, means if it is accuracy wise, means this one. If you want errors wise, means calculate the train RMSE separately, calculate the test RMSE separately. If you want to calculate errors, means RMSE we have to select. We should not select MSE because the units also get squared off. That is the problem in the MSE. So RMSE we have to select. Once our modeling, prediction, evaluation, three things are completed. Now selection. Next heading is called as selection. Whether this model has to be selected or not selected will be decided based on that if the train accuracy is equal to test accuracy with plus or minus 5% difference. That side or this side 5% okay. Second one is with cross validation score. At the time only I have told you, right? While explaining, don't write. Again, you have forgotten, you are writing, right? Yeah, you can continue as per your choice. Whichever you feel easy, that one you select. Right? So selection is based on the cross validation score. Whatever the cross validation score is equal to test accuracy or not. This is the check and check. If these two checklists and if these above two conditions satisfies only, that model is a good model. If one of the condition is good and one of the condition failed also, it is called as a bad model. These two conditions it has to satisfy. Along with that, it has to satisfy the client requirement. The third one is client requirement. If the client asks with 90% accuracy, but model is giving only 75, this model is not suited. We have to change the model. Like that, we have to try with multiple models. So I'm going to show you for one data set. I will try with 200 models, and out of that 200 models, which is the best model, I will select. Okay. So I will show you multiple models. How you have to select also, I'll explain one by one. Don't worry. Now, this modeling is clear, prediction is clear, calculation is clear. Manually also we have done. Selection is train accuracy and test accuracy, I have told you. And now cross validation score. Now what is meant by cross validation? Before moving to cross validation, first selection. Within the selection, first one we have to check whether the train and test accuracies are equal or not. If both of them are equal, means called as good model. If both of them are not equal, means it is called as bad model. Within the bad model, again we are having underfitting and overfitting. Within the bad model only underfitting and overfitting is there. So now let us start with respect to concept of overfitting, underfitting. Both of them are bad models only. Lucky, I'm having undo. Otherwise, generally you will open the camera, right? I think you have forgotten the flow. Okay. Done. So now next heading is overfitting and underfitting. Both of them are bad models only. Both of them are bad models. Both are bad. Okay. This one overfitting is bad and that one also bad model. Both of them are bad. Overfitting is called as train accuracy. When your train accuracy is greater than test accuracy, it is called as overfitting problem. If your train accuracy is less than test accuracy, it is called as underfitting problem. It is called as underfitting problem. In an interview, if they ask what is meant by overfitting, means, sir, my model performing well on train data. Train data, it is performing very nice. And performance is poor or worst. performance is poor or not good on test data, then it is called as overfitting problem. So train accuracy is very high means accuracy is very high means it is performing very well. Accuracy is low means it is not performing very well. Same thing, opposite to this is this one. So your model is performing on the test data very well. On the train data, it is not performing very well. It is called as underfitting. Right? Just opposite to this. Opposite. Now, how many will write in the notes also opposite word and how many will write sentence? Let us observe. Now, whoever writes the copy paste of opposite same word, they are called as overfitting problem. Whoever writes clearly the sentence, they are called as good. Whoever not even writes this one, completely they'll ignore and they'll see like this one in a underfitting problem. Overfitting is called as with respect to variance problem. Underfitting problem is called as bias problem. Bias problem is with respect to this. So now you will understand the difference very clearly. Bias means our model will not be trained well on the training data. On the trained data, it will not perform very well, but there will be a high training error when the model is trained with the data. Variance means if you are trained with your data on the training data and obtain a very low error. Error is very low. Error low means accuracy is very high. Train accuracy is very high. Upon changing the data and training of the same previous model, the error is very high on the test data. Then it is called as variance. This is called as, so now you can observe this one clearly. This example will be very clear. So in this example, just everyone knows shooting game, right? So now the person is shooting on the, using the bow and arrow or whatever it is. Now this particular, here if you observe, all the data points are very close to each other. All the data points are very close to each other means variance is low or higher. The variance is low. If the data points are very close to each other, data points are close to each other. What is the meaning of that? If you apply the mean, what happens? From the mean, the deviation, what is meant by variance? Variance is nothing but x minus x bar only. Na? X bar will be center, mean. X will be very close. Na? So the deviation will be very small. Since the deviation is very small, the data points are very close to each other. Close to each other means, close each means, what is the meaning of that? Variance is low. In this case, the variance is low. So it is called as low variance. And it is close to the target. Within the target, it is very close. So it is having the low bias. Now, whereas this one, if you observe, the data points are somewhat far away to each other. Now in this, the variance is very high. But everything are close to the target. Close to the target. Every point is very close to the target, but between the data points, the variation is very high. Now, in this case, variance is very low, but completely it is far away from the target. This one is far away from the target. At the same time, data points are also very high. So, in this case, low bias, low variance. This is called as good model. Low bias with high variance is called as overfitting problem. High bias and low variance. Variance is low, but bias is very high. Low variance is low means that it is going to have the data points are very close to each other, but it is not meeting the target. This is called as underfitting problem. This is worst one. No need to discuss first. Worst to worst. These two are called as bad. This is called as worst. So no need to discuss about this one. Right? We require this kind of models. We require with respect to this type of models, which give with respect to good train accuracy and good test accuracy, which is almost close to each other. Right? So simply to say, in the interview, they'll ask what is meant by bias variance trade-off. Bias variance trade-off means if the model is having low variance, low bias, it is called as good model. If it is having with high variance and low bias, it is called as overfitting. And low variance with high bias, is called as underfitting. Variance is low means changes is low. If the change is low means the accuracy is very high. Accuracy of train accuracy is very high, but test accuracy is low. Variance means nothing but high train accuracy. Variance means in your words, it is called as train accuracies. Bias means test accuracy. Bias is also called as test accuracy. High train accuracy is there, low test accuracy is there, which is called as overfitting problem. Low train accuracy with high test accuracy is called as underfitting problem. Simply variance means train accuracy, bias means test accuracy. Simple words. Not accuracy with respect to errors. We have to discuss as per the errors. So we require both of them. Errors should be very low. So you don't ask that, sir, low variance means obviously low accuracy, na? Low test accuracy, low train accuracy. It is a good model. No, error wise I'm saying, not with respect to accuracy wise, error wise. Okay. The cross validation. Cross validation means nothing but the entire data. Okay. Whatever the entire data is there, assume this is the entire data. This entire data, inside this, you are using 80% randomly for training purpose, 20% for testing purpose randomly. Instead of that, divide the data into 4 or 5 equal parts. Choice is yours. For example, I am dividing the data into 5 equal parts. 1, 2, 3, 4, 5. 5 parts I have divided. Now, first part is 20% of the data, 20% of the data, 20% of the data, 20% of the data, 20% of the total 100% of the data I have divided into 5 equal parts. Assume there are 100 records are there. Out of 100 records, I have divided that one, each one into 1. 20 records into 1 part, 20 records 1 part, 20 records 1 part, 20 records 1 part, and 20 records 1 part. Now, what I'm going to do is, first I'm going to use these first 4 sets. These 4 sets I'm going to use for training purpose. That is nothing but first 4. First one I'm using for training, and last one I'm using for testing. Okay. Next, second, again I'm going to take immediately. First one I'm going to use for training. This one I will use for training, and this part this time I will use for testing. Next, after this, again I will take from the starting. Now this time, these 4 parts are used for training purpose, and this part is used for testing purpose. And next time I'm going to again from the starting first data, again I'm going to take with respect to this one for training purpose. This part I'm going to use for testing purpose. Second part for testing purpose. Now next time, again I'm starting from the starting. Again I will take with respect to these 4 parts for training purpose and the first part for testing purpose. Now what happened? Every record was used for training. Every record was used for testing. There is no random selection. Each and every part was used. Every record, 100 records are there means each and every record was tested one time at least. Each and every record was used for training purpose. So this is called as cross validation. So now dividing into parts, I have told you, right? That parts are called as fold. How many parts you have to divide? That is choice is yours. That is the reason it is called as k-fold cross validation. K is not the fixed number. If the K is fixed number, it is called as 5-fold cross validation. If it is K is 2 means 2-fold cross validation, they will fix now. Their number is not fixed. The number you can select as per your choice. So it is called as k-fold cross validation. Generally, we'll go with K is equal to 5. At the same time, it is not mandatory. Now, okay, sir, k-fold cross validation, okay. First time you have got test accuracy of 80%. Second time you have got 84%. For this fold, you have got 84. For this fold, you have got 90. For this fold, you have got 80. For this part, you have got with 81. Now, what you are going to do? Average of all of them. That is called as cross validation score. Cross validation score means test accuracy. Average of all the test accuracies of each fold is called as cross validation score. So the same thing was there in the PPT. Okay. So here the entire data, this entire data I'm going to divide into 4 parts. First part, second part, third part, and fourth part. Equal. Sir, equal means, for example, 100 records are there. 100 records you can do equally into 5 parts. Okay, each part will have 20. 99 only is there. Then how we are going to divide? Don't ask this type of silly questions. It is going to make round figure. For one of the fold, it will be going with 20, 20, 20, 20, and one of them will be 19. Obviously, it can't divide the data, right? So just it is going to apply in that way. Now, for example, the entire data was divided into 4 parts. Now, see here, testing part I am using first fold. Remaining 3 folds I am using for training purpose first time. Second time I am using this part for testing purpose. Remaining 3 folds I am using for training purpose. Third time I am using these 3 folds for training purpose and testing purpose, third fold. Fourth time, fourth fold. First time, first fold. Second time, second fold. Third time, third fold. And fourth time, fourth fold. Fold means nothing but part. Each part I am using different times for the different testing purposes. After applying this one, I am calculating what is the accuracy. Every time I will calculate the accuracy. Means you don't need to do manually. Automatically, there is function called as cross-validation score. It will only apply for loop. So it will select it will divide the entire data into parts. Whatever the data you have given inside that, it will divide the entire data. So now first, I'm going to give with respect to whatever the data, it will apply this one. And after that, it will calculate for this one, what is the test accuracy. And it will apply the test accuracy for this one, test accuracy for this one. Once the 4 of them is calculated, just it will take the average of 4 of them. This is called as cross-validation score. Is that clear? That is the meaning of cross-validation score. Now, I'm going to check my test accuracy is equal to the cross-validation score. Then only I have selected a correct split. If the test accuracy is not matching with the cross-validation score, means your model is not correct. There might be some error. Maybe some error due to the train test split, whatever the random state is there, that one, or anything. Reason is anything. So what I'm going to do is, so train test, whatever the train test split is there, generally I will go with the train test split of 80:20. And cross-validation, I'm going to take K fold is equal to 5. So that every time 80% will be used for testing purpose. If you are going with K fold of 4 means 75% of the data will be used for testing purpose. 25% of the data will be used for, 75% is used for training purpose. 25 is testing purpose. So while designing the model also 75:25 you maintain. Right? So generally we'll go with 5. CV is equal to 5 is the most standard one, common one. But there is no rule. At the same time, there is no rule. Sir, if there is no rule, then how we have to identify? That is called as tuning. Next concept is called as tuning. Tuning means when we don't know exact answer, we are identifying the, trying to get the correct answer. For explaining this tuning concept, I will explain with you a simple example. In the olden days, we used to have the radio where we will be having some knob and we have to rotate that knob. Then we can get the exact frequency. If the frequency matches, then we'll get the clearly the sound. For example, in my house, there is a radio and 97.6. The present frequency was there, present. And the exact answer is 98.3 is the exact answer. Okay, 98.3 FM is the right answer, but I don't know this one. That number I don't know. I am in the 97.6 only. What I'm going to do is just I'm going to rotate the knob slightly. And I will check the audio is very clear or not. Radio, whatever the songs or whatever it is having, I will check the audio. And if it's not clear, 97.8, 97.9, 98. I will try with 98. After that, 98.1. After that, 98.2. After that, 98.3. Here I'll get the audio clearly. But maybe 98.4, still more audio I may get. Who knows? So I will try with 98.4 also. When this quality has dropped, then I will decide myself, oh, answer is 98.3. If the quality was increasing, I will increase. Still, I will continue. If whenever the quality was dropped, again I will come back. Slightly, I will again come back. The same thing is called as tuning. Here also in the model also, we have to do the same thing called as tuning. So we have to try with different values. Tuning means nothing but different values try, which is nothing but trial and error method. Which is nothing but trial and error. Blindly, it is called as trial and error. We don't know exact answer. We have to tune according to the data set. For example, in my data set, K value of 5 is suited. Means for every data set, K value will be 5 will be suited. No. Maybe, may not be. So according to the data set, we have to try. So how we have to try means by applying the for loop for I in range of from 1 to what are the number. If you give 10,000 or 20,000, your system will die. If you give with 10 means your system will be alive. Right? Otherwise, if for K of 1 means it has to do means split the data. K is equal to 2 means it has to divide the two parts, and after that it has to apply for one part separately, second part separately. It has to calculate the test accuracy. So much of things it has to do, right? So generally the K value will not cross more than 10. In the real life, entire real life will not cross more than 10. But exact value we don't know. We have to check every time. For which one is better, that one we have to finalize, which we used to call as tuning. Now by applying this evaluation, whatever the evaluation is there, and by applying the selection, whatever the selection criteria is there, and according to the tuning, finally we'll decide which model is best model. After trying with all of them, finally we'll come with a solution. For a given data set. For a given data set, we have to evaluate, we have to tune, we have to do. So all these things I will do one by one. So nothing random will be there. None of them random is there. So purely everything will be one by one. We'll come with everything one by one. Yesterday, as one of the students was confused with respect to random state, how we have to select the number. Random state means, exactly to be more precise, what is meant by random state? Random state means nothing but fix the data. You want to fix the data or you want to rechange the data. Fix the data is equal to true. Whenever you have written some number here, the data will be fixed. It will not rechange. Otherwise, every time you execute, the values will change. For example, you have not given the random state in the train test split. You have done the entire coding and you have got 90% test accuracy. You have brought to me and I have executed. Now suddenly it will fall to 86. So for what data you have got 80, 90, the same data should be saved, means that number should be fixed. But this number I don't know. Again, if you don't know, means tuning only. Again, apply for loop. I will show you that one also. Apply the for loop. Take the random state of 1 to 100 or 1 to 10,000, whatever the number. And out of all of them, which is the best one, which gives the test accuracy very high, that random state number you have to select. And that random state, once it is selected, the data should be fixed. Once the data is locked, now for this data, we are going to apply the different models. Data should not change. For example, here, let us assume there is two trainers are there. Trainer 1, generally I will explain with this example, trainer 1 and trainer 2. Now, out of these two trainers, which trainer is the best trainer you want to see is, both the trainers has to deliver their lecture on the same students. To the same students, they have to select the same students. Whatever the students are there here, and the same student should be here also. And he has to explain the same topic also. The trainer 1 and trainer 2, both of them has to explain the same topic, but in their own way. Topic should be the same. Now, for example, assume that trainer 2 is SRK. Trainer 1 is some XYZ. Now, we both are there and you are the students. Now, first XYZ will come and he will explain some linear regression topic. Now, I am explaining the linear regression topic. Now, you are going to decide who is the best. Now, you can decide. For example, I have explained linear regression and he is explaining some other algorithm, which is the easiest algorithm. In the machine learning, some algorithms will be tough and some algorithms will be easy. Na? In that, one of the algorithm is called as KNN, which is 5 minutes algorithm, which we can complete in 5 minutes. Assume that he has explained a simple example of KNN and he has told very simply. You will feel that, oh, machine learning means this much one, yeah. You will feel like that. That for that algorithm, it is okay. But all the algorithms will not be like that, right? So when you are explaining with the same topic for the same students, you can judge easily which trainer is best. Judgment is easy. For example, you have explained to a different student. Topic is same, but different students. Now, how you can judge? From these students, they don't know what other trainer is saying, right? So when you want to compare between the trainers, when you want to compare between the trainers, you have to take the same students and same topic. Then the comparison between these two will be more accurate. Similarly, here, same students and same topic is called as data. Trainer is called as ML algorithm. If you want to compare two different algorithms, data should be same. By changing the data, you can't exactly say that this algorithm is doing best or that algorithm is doing best. So in order to compare between the algorithms, data should be same. Data should be same means you have to fix some random state number. That is the reason we have to fix the random state. If you don't fix the random state, data will change. Is that clear now? The reason is clear. So once we fix the random state, the data will be fixed. X-train data will be fixed. Y-train data will be fixed. Now using the same data, you give for the algorithm 1, algorithm 2, algorithm 3, algorithm 4, all the algorithms, you give the same data. Now which algorithm gives the maximum accuracy? Select that algorithm only and predict the future data. Which algorithm gives less accuracy? Remove that one from your system. Simple. The same thing will be done in the companies. We will try with all of them. Whatever the possibilities are there, every possibility we will try. Out of all of them, which is giving the maximum best one, that we are going to select. Whatever the different options are there, every option we have to try. Is that clear, guys? So once we have to do the data cleaning, data wrangling, and once the train test split is done, now you should not disturb the data. Data should not be disturbed. Before to that only you have to do anything. Once the data train test split is completed, data is finalized. Now you have to apply the same data on the train data, whatever the train data you have got, the same data has to be shared to the algorithm 1, same data has to be shared to the algorithm 2, and then you have to compare between the algorithms. And for the data set, which algorithm is best, that one you have to select. For example, I'm having algorithm 1 and algorithm 2. Algorithm 1, algorithm 2, algorithm 3, 4, 5. And I know that algorithm 5 will give the best answer. If I know this answer, then why we have to read the remaining 4? Directly we can read 5th algorithm only. Na? Why time waste for reading? No need to read also, right? For my data set, which algorithm will give the better performance? We don't know. We don't know. So we have to try with all the possibilities. If I know that algorithm will give directly this one, for every data set, this is the best algorithm. If I conclude like that, then why we have to learn remaining 4 algorithms? If I know this is the answer, miss. So for my data set, anything can be there. Now assume that algorithm 1 has given with test accuracy of 92%. Algorithm 2 have also given the test accuracy of 92%. Both of them, algorithm 1 and algorithm 2, both has given the same accuracies. Test accuracies, same of them are satisfying the client requirement. Not overfitted or underfitted. It is having the test accuracy is equal to cross validation score. Everything is satisfying. Every condition is satisfying. Now, out of these two, which is the best one, miss? Which is having less time? Now, time will come into priority. In the starting classes, do you remember I told you that I don't want that with respect to quick answers. I want with respect to correct answers. Do you remember? My choice with respect to accuracy is first, later time is the second one. In the machine learning and data science, first choice goes with respect to accuracies. If the accuracies are same, then we'll try with which is giving in the less time. That particular model we'll use for the deployment, and in the future class, we'll use that one. For example, you are saying that IRCTC, what is the probability that your seat will be reserved if it is in the waiting list? You can see in the IRCTC website, right? That is working on the one algorithm, machine learning algorithm. After checking with all the algorithms on the past data of IRCTC, whoever has booked and whichever the tickets has been already confirmed, by observing that data, they have decided that algorithm. And that algorithm only they have deployed in the IRCTC website. Finally, they have selected one algorithm. For selecting that algorithm, they have worked on the multiple algorithms. Is that clear? So by applying all these things, tomorrow we are going to start the first project, whatever we have done in the SAYS, that is TV, radio, newspaper, which one we are discussing. And the problem is relation between total spend versus SAYS is there, right? That we are going to continue in the tomorrow's class. I will show you with respect to all of them. Now, what are the things I have done? Modeling, I will show you. Prediction, I will show you. Train accuracy, test accuracy. cross validation score, and whether it is satisfying the model, my requirement, client requirements, it is satisfying or not, whether it is a good model or a bad model. And if everything is fine, then finally what you have to do, we have to save the model and we have to share to the deployment team. How to save that model and how to share, that one also I will show. End to end completely I will show you on the algorithm one. For every algorithm, not only first algorithm, every algorithm I will show you like that.